Hey guys, so today we're going to be talking about variance. So variance is just a measure of spread of different data. So it's being able to, you have this different data set or different probability set, and then you have to know how far spread out are the results. If you have test scores, are they all close together? Are they really spread out? So whenever I hear variance, I always interchange it sort of with spread. So it's a calculation. So it's a measure of spread. So if you ever get confused about what is variance, always think back to this spread. Is the data spread out? Is it close compacted? How much variance is there between the points? And so you can sort of interchange those two terms. So what do I mean by variance? So let's take an example. Test scores. If you have test score of, let's say, 40%, 50%, and 60%. So let's say that's group A. And then group B, you have 5%, 45%, and 85%. Then you can see from these two data that B is more spread out. Between these two values, there's a bigger gap. Between that's plus 40%, and that's plus 40%, which is a lot bigger compared to 40, 50, 60. Then if we added another one, C, you could have 49%, 50%, and 51%. So even then, C is even closer. So if you relate that to spread, then for the variance, you can say, well, the variance for this one's going to be the lowest. The variance for this most spread out one is going to be the highest. The variance for this one is going to be higher than B, but lower than C. So I'll go on to calculating how you actually calculate variance and what it measures. But before you go into that, before we relate it to probability, it's really important you understand the concept that variance is just talking about the spread of the different data, the different sets. So they just don't have to be test scores. I'll give another example. You could have price of cars. So you have price of cars. So group A could be 5,000, 6,000, 7,000, and then group B could be 3,000, a $20,000 car, and then a $100,000 car. So obviously the variance for B is going to be higher, the variance for A is going to be lower. However, it brings up an interesting point about $1,000 for cars may be a pretty small variance and not that much variation. But then if you go $1,000 and compare it to the price of, let's say, a t-shirt, then obviously $1,000 would be a huge variance. So it does depend on what you are measuring. So with the variance, how do you know that something's far? You can look at these sort of values and think, well, 3 to 20k, 20 to 100, they do seem pretty spread out. The lowest is 3, the highest is 100, A is 5, 7. So the way we measure it is the mean. So if you remember, if you have all these sort of data points spread out along, let's say, so this is sort of the timeline, so it could be test scores, or it could be, let's say, the 3k to 100k. Then you might have some random values there. They're mainly clumped around there, sort of like that, maybe some there. Then what you do is, you know that the mean lies somewhere. So let's say the mean lies here. So effectively with the variance, we look at every point and we think, how far away from the mean is it? Well, that's pretty close, so that's going to be low variance. Low variance. But then, if you start to go further away, you can see that these really far values are quite far away from the mean. And then even further is that one over there. So when we measure variance and we talk about spread, we think, how far away are the values from the mean? Which if you think about it, that's because the mean is sort of the center, it's the average. You're effectively saying, how far away are the values from each other? How far away are they clumped or are they spread out? So now move on to how do we actually calculate the variance. Now there are lots of different formulas, so if the one I'm about to write down isn't the one that you're used to, and that's fine, but they're all the same. So with the variance, that's how you write variance, by the way, just like how the expected value or the mean was like EX. Variance is the variance, and then brackets X or whatever the distribution you're talking about. So I like to think of it as xi minus u squared, and then 1 over n. So you use this formula less in probability, as this doesn't relate to a lot of the examples we'll do, but it's a good way to conceptually understand, and then I'll show you some of the other formulas. So what this is effectively says, that's a sum of symbol, by the way, is it's the sum of all your values minus the mean squared and times 1 over n. So that's the amount of values. So you can sort of think, or maybe a better way to write it is you could sort of think about it like I. But what this is for is when each value is equally likely. So equally likely. So don't worry too much about the 1 on n, but just remember that's equally likely. It's when, if you're working at the average of 3 values, you can go 5 plus 6 plus 7 over 3, when they're equally likely. So that n just represents that sort of 3, because you have 3 terms. So we'll have an example of test scores. One, you have 50 marks, 60 marks, and 70 marks. So we'll just have 3 students. So n equals 3. They're each equally likely to occur. So you have one student get 50, one student get 60, one student get 70. Well, we can straight away see that the mean is 60. And you can calculate that by going 50 plus 60 plus 70 divided by 3. Remember, this is for equally likely, just so we can understand conceptually what variance is. So the mean is 60. So what the variance is it's 1 over 3, so that's 1 over n, times 50 minus 60 squared, plus 1 over 3 times 60 minus 60 squared, plus 1 over 3, 70 minus 60 squared. So the 70, the 60, and the 50 come from your test scores, and this is 60 represents there. And then the 1 over 3, you can sort of think about it as the 1 over 3 represents sort of the probability of 70 occurring. So just have a look at this and try and understand how you have this formula, 1 over n, so in each of these, and then you have the values, the test scores, then you have the variances. So try and understand how this happens. So once we do some calculations, you'll see how this formula works. So we have the variance of x is equal to 1 on 3 times negative 10 squared plus 1 on 3 times 0 squared plus 1 over 3 times 10 squared. So negative 10 squared gives you just 100, and over 3, so it gives you 100 over 3, plus 0 squared is 0, plus 100 over 3, which gives you 200 over 3. So some important features in this. Firstly, the 0, why is this giving you 0 for 60, but 50 gave you a higher result? Well, if you think about variance, it's a measure of spread. So 60, the mean was 60, so they're exactly the same. So there's no spread from the mean, so that's why it's 0. It's not adding anything to the variance. However, 50 was 10 sort of units or marks away from the mean, so that's why it was minus 10 and 10. Now the squaring may seem a bit strange, but what happens when you square it is that you get rid of the negatives. So you have negative 10 here, and then 10. But because you square it, a negative number squared is just positive. So it doesn't matter if all your values are really far away from your mean in the positive direction. So let's say the mean was 60, and you had a few marks that were 70, 80, 90, or you had marks 50, 40, 30, either way, you're going to get a positive value to variance. So variance is just measuring the spread away from the mean, irrespective of which side it is. So if you think about 50 and 70, what about if the marks were, let's say, 40 and 80? Well, there'd be greater spread. And instead of having 50 minus 60, you'd have 40 minus 60. So you get 20 squared. So you'd start to get 400. Like 20 squared is 400 plus 400, so you get 800 over 3. So the variance would start to go up if you added these two values in. And remember that the 1 over 3 is just a probability of that number occurring. So now, putting in the variance into a form that you are likely to use. So this is more for probability. So the variance of x is equal to the of x minus u squared. So the x minus u, so that's the mean, squared, so we just saw where that came from in the previous formula. And so this expected value really just comes from the 1 over n, because when we start to go with probability, we start to realize that you could have the previous example 50, 60, 70, but this could have 40% chance of occurring, this could have 20%, as obviously a lot more students may be 60, and this may have, let's say, 10%, and there could be another value, etc. So you have to start accounting for the probabilities. As if you have a set of data, which the mean is 95% of the time occurring, then you may say it's not that spread out. Even though the values may be spread out, a lot of the time you're still going to have close values. So that's why you need to take into account probability. So that's where this formula comes from. So the expected, and that's the same thing. Another one, so you can expand this out and then simplify, is you get the variance of x equals e to the x squared minus e to the x squared. Now note that they're not the same thing. With this, if we talked about previously in the expected laws, when you square all the terms first and then you find the average or the expected value, that's different from finding the expected value and then squaring it. So another way you can write that is expected value of x squared minus the mean squared. And so you use this formula more when you have a table value, and then you can calculate it. So quickly, just standard deviation. You can also hear this term standard deviation. I'll talk about this more later. However, the standard deviation is literally just the square root of the variance. So that's that easy. So the variance symbol is that squared, and the standard deviation is just that. So I'll talk about that more later. However, if you do come across the term standard deviation, just think it's another measure of spread, and it's literally just the square root of variance. So it's the same way to calculate it, but then you just have to take the square root. Thanks for watching, guys.